I want you to try and remember two things. First, I want you to try and remember learning how to ride a bike. Maybe you have a scar you received when you flipped over the handlebars. The next thing I want you to remember is how to ride a bike. The reason I asked you to recall both of these memories is that they belong to two different designated realms of memory. Memory is a fluid and dynamic system that is exceedingly complicated. To this end, psychologists have attempted to divide memory up to make it easier to study. There are two main categories. Explicit memory is a memory that can be intentionally and consciously recalled. This is your memory of riding a bike, and falling over the handlebars and skinning your knee. The other is implicit memory, which is an experiential or functional form of memory that cannot be consciously recalled. This is your memory of how to ride a bike or how to balance. These are often not tied to a visual memory, but are more like muscle memory. The examples of implicit memory include using language naturally, driving and reading, and answering multiple questions in the test, etc. will be natural. Let's look at explicit and implicit memory in a little more detail and see how age influences these. It is an experimental or functional form of memory. Explicit memory consists of a great deal of highly personal memories related to time, space, and people. It is totally different from implicit memory. Now, if we look at the examples of explicit memory, it includes remembering people's birthdays and answering multiple questions on the test.
So when we talk about the polar regions, just to clarify exactly what we mean, we have first of all the Arctic at the top of the Earth and the Antarctic at the bottom. So the Arctic was named after the Greek word for bear. Now surprisingly it's not after the polar bears that live in the Arctic, but it's after the Little and Great Bear constellations that can be seen in the sky. Now the Greeks also hypothesised that there would be an anti-Arctic, which is how we get the name Antarctica. But of course it wasn't discovered until much later on. Now these regions are opposite in many ways other than just their names and their location on the globe. So if we look at the Arctic first of all, the Arctic is actually ocean surrounded by land. So we can see here, this is the UK down here, and this is kind of Russia, and then America and Canada around here. So there is a bit of land covered in ice in the Arctic, which is Greenland here. But mostly all this area here, surprisingly a lot of people don't realise that this isn't actually land. The North Pole isn't on land, it's just one big ocean.
But we can really thank the great exhibition of 1851 for giving us the world's premier taxi service. For it was going to this exhibition, this fabulous exhibition of inventions from all around the four corners of the empire, that the visitors were appalled, dismayed and vexed by their journeys to this exhibition, because the cabbies of the day in their horse-drawn carts were absolutely terrible, could not find their way to this exhibition. And so, at great public outcry, the London authorities set up the Public Carriage Office, which is an organisation that still exists. You can take a short walk to Penton Street up the road. And this Public Carriage Office took on the responsibility of licensing all major taxi drivers in London. All taxi drivers from 1851 onwards had to pass what is now known as the London Knowledge, this phenomenal knowledge of London. What is the London Knowledge? It's the ability to remember the 25,000 streets, how they're all interconnected, and know all the main arterial roads in and out of London. Cabbies need to know all this, plus 1,000 points of specific interest, cafes, bars, public offices. They need to know them all as part of their training.
A new study of fish called sticklebacks shows that shy individuals actually prefer to follow fish that are similarly timid. This is Scientific American's 60-Second Science. I'm Karen Hopkin. This'll just take a minute. Researchers had trios of sticklebacks with known personalities play follow the leader. The fish were placed in a tank that had some plastic plants at one end and some food hidden at the other. In some of the groups, a bold fish and a shy fish acted as leaders, while another shy fish followed. And in other groups, it was a bold fish that did the following. The researchers recorded whether the follower sallied forth more frequently with the fish that was behaviorally similar or the one that was different. What they found is that shy fish were more likely to emerge from under cover when an equally wary fellow was already out there. Bold follower fish did not seem to care as much which leader they followed. Of course, no matter which fish a stickleback chose to stick with, the bold fish did lead more joint expeditions over the course of the experiment than their more retiring friends. That's because the bold fish initiated more trips, regardless of who might be tailing them. The researchers write that when offered a choice of leaders, sticklebacks prefer to follow individuals whose personality matches their own. But bolder individuals may, nevertheless, be able to impose their leadership, even among shy followers, simply through greater effort.
As Joanne pointed out, only one country, tiny little Bhutan, wedged between China and India, has adopted the gross national happiness as the central index of government policy, and actually has had a good deal of success in education and in health and in economic growth and in environmental preservation, and they have a rather sophisticated way of measuring the effects of different policies on people's happiness. But they are the only country to go that far. But you're now beginning to get other countries interested enough to do kind of white paper policy analyses about whether happiness research, what effects would it have if we used it more for public policy. You're beginning to get countries like Australia, France, Great Britain that are considering publishing regular statistics on happiness. So it's beginning to become a subject of greater interest for policymakers and legislators in different advanced countries.
Welcome to your very first tutorial in biology. Now, in this video series, what I want to do is I want to talk to you guys about many different topics concerning biology. For example, I want to talk to you guys about DNA and genetics and cells and bacteria and life and a whole bunch of interesting stuff. But since this is the very first video, I think what we should do in this video is just stick with the very basics. And the first thing I want to do is talk to you guys about what is biology. So let's go ahead and answer that question. And the definition of biology is this: the study of life and living organisms. Alright, that makes sense up to a certain point, up until organisms, because you may have heard of organisms before, and you may have your own definition, but the scientific definition of an organism is a living thing. Well, that's easy. We know what living things are. I'm a living thing. Plants, grass is a living thing. My puppy, named Old Dan, cutest puppy ever, by the way, is a living thing. But whenever we talk about living things, believe it or not, things get kind of complicated, because then you have to ask yourself, what is life? Well, of course, if you ask your grandma or your best friend, or even if you ask a philosopher, what is life? Everyone is going to give you kind of a different definition of their outlook on life. However, whenever scientists and biologists were first deciding, you know what is life? That's the problem that they had. Everyone had their own separate definition of life itself. So what they needed to do before biology was even invented, which is of course the study of life, is scientists needed to agree on the definition of life.
There's sugar in a lot of foods where you don't expect it. And of course, there's lots of sugar in donuts or ice cream or pastries or other things that are sweet, candy of course. But there are other places where you see it and you don't necessarily expect it. So as an example, peanut butter. Here's a list of ingredients from Skippy peanut butter, and you see that sugar is the second most common ingredient. Excuse me, you may know from reading food labels that these ingredients in any food label are listed in order of how much there is in the food itself. So sugar comes right after peanuts. Here's another example, beef stew. You wouldn't necessarily expect to find sugar in beef stew, but it's there. Now it's down the list of ingredients. It's actually toward the end. But if you look at the marketing of this and look at the can, it says there's fresh potatoes and carrots, but actually there's more sugar in this than there is carrots. And so you wouldn't eat something like beef stew and expect to find this to be the case.
This is a kind of object that you're probably all familiar with when you hear the term robot, but I'm going to show you the very, very first robots. These were the very first robots. They were characters in a play in the 1920s called Rossum's Universal Robots. And the play was written by a Czech writer called Karel Čapek. And basically, these robots, people tend to think of robots as kind of cute, cuddly toys or, Hollywood depictions kind of devoid of politics. But the first robots were actually created and imagined in a time of absolute political turmoil. You just had the First World War, finished. That had a devastating impact across Europe. And so people were kind of reflecting on what does it mean to be human, what makes us human, those kind of questions. And this kind of context is what inspired Čapek to kind of write this play. And interestingly, these robots being human, they are actually in the play assembled on a production line, a bit like the Ford manufacturing production line. So even though they are human, they are assembled, and these robots are designed to labour, and that is their primary purpose in society.
Climate change – some adverse effects of climate changes to agricultural productions. Some lands are unsuitable for growing crops. There will be millions of people facing hunger in Africa in the future. Climate change will result in less production and less food. It is difficult for developing countries to deal with climate change due to their financial status and other issues. There are many people living in hunger, especially in Africa. The climate change has devastating effects on world economy. The tropical areas on Earth are dry and hot, and are originally not suitable for food production. The change of the climate leads to extreme weather conditions such as flood and hurricane, which exacerbates the food production. As a result, it leads to a continuous decline in food supply annually around 10 to 17%. And this trend is perceived to be continue in the future by 2070. The regions suffering the most will be some African countries.
But I'm going to focus on today is really different, larger forms of genetic variation involving essentially gains, losses, and inversions of sequence. So showing here is 30 in a simple diagram. We have an example of some structural variation operationally defined as events greater than a kb in size. So we have pieces of DNA that sometimes become deleted. We have pieces of DNA that sometimes become duplicated on chromosomes and regions which can be, in fact, inverted or turned around with respect to another orientation. So this very busy map here represents probably about 3 years of work in my lab, just to kind of characterize the general pattern of structural variation in 8 human genomes. So shown here are different human chromosomes from African or from non-African. The distinctions really aren't that important. But what I'm showing you here is the presence of insertions, deletions, and inversions as red, blue, and red, blue, green. And so each line here represents a different human genome that has been analyzed, looking for structural variation of events greater than 5,000 base pairs in size. So a couple things you can maybe get from this is that you can see there's a lot of genetic variation out there. This is above the level of a single base pair change, and most of the events that you're seeing here are essentially inherited. But we now know, based on studying roughly about 2,000 human genomes, but there's a significant fraction of a very large events, hundreds of kb in size, that are either individually specific or specific to specific families. So this is kind of changing our view of the dynamic nature of human genome.